So we're looking at momentum and impulse, and in this homework assignment you're looking at collisions. So what I want you to do for these 4 problems that you have is first say, what type of collision is it? Elastic or inelastic, and why? The total momentum of each cart, the green and the blue. The total momentum, meaning of both carts or the system, before and then after the collision. And then the final velocity of the blue cart, which could be the final velocity of both carts if they're stuck together. You can consider it and use correct units in the charts drawn. The first example we're going to look at is a green cart with a mass of 5 kilograms and a velocity of 3 meters per second collides with a blue cart with a mass of 2 kilograms and a velocity of 4 meters per second. The 2 carts stick. What's the final velocity of the 2 carts? Let's take a look at this example. What we know is it's an inelastic collision because the 2 carts stick together. Now let's look at the momentum before. The momentum of the before is 5 kilograms for the green times its velocity of 3 meters per second. We're going to consider the right positive. That gives us 15 kilogram meters per second. For the blue, we have a mass of 2 kilograms, and we're going to consider left negative, so negative 4 meters per second. 2 times 4 is negative 8 kilogram meters per second. 4 is that 15 kilogram meters per second plus negative 8 kilogram meters per second, or 7 kilogram meters per second. That 7 tells us that the total momentum is in the right direction overall. Afterwards, we know conservation of momentum says the momentum before is the momentum afterwards. 7 kilogram meters per second afterwards. Now, let's see how that's divided up. So we have the 5 kilogram green cart. We have the 2 kilogram blue cart. And we know their momentum is 7 kilogram meters per second. So we know 7 equals the mass. Now is the 2 carts stuck together, so it's 5 plus 2 is 7. So I pulled the unit out of there so you could see 7, the total momentum, equals the mass times velocity. We divide both sides by 7 and we get that the velocity is 1 meter per second for both of the 2 carts. 1 meaning it's moving towards the right. We have a green cart, and the green cart has a mass of 4 kilograms and a velocity of 1 meter per second. So to the right, collides with a blue cart with a mass of 1 kilogram and a velocity of 4 meters per second left. The green cart rebounds, moving with a velocity of 1 meter per second left after the collision. So we know that that's the green cart, and we know because it rebounds or bounces that it's an elastic collision. Now let's see what the momentum before would be. I have a 4 kilogram cart at 1 meter per second, so I get 4 kilogram meters per second, positive meaning to the right because it's a vector. Blue cart, I have 1 kilogram and negative 4 meters per second, negative meaning it's moving the opposite direction or to the left, for negative 4 kilogram meters per second. So the total momentum before, for the total momentum before we get 0 kilogram meters per second. The green's got 4 kilogram meters per second right, the blue has negative 4, so meaning left. Those momentums add to 0, sum to 0. Now, conservation of momentum tells us that the momentum before is the same as the momentum afterwards. So afterwards, we know we're still going to have 0 kilogram meters per second. However, the green cart rebounded left, so it bounced back left. That means if there's 0 kilogram meters per second overall, we know the blue cart must be moving right. Let's see how fast. The green cart is moving at negative 1 meters per second, so 1 meter per second left. So that's a momentum of negative 4 kilogram meters per second. We know my total momentum is the green cart's momentum plus the blue, and that sums to 0. So if the green cart has negative 4, or 4 to the left, the momentum of the blue cart must be positive 4, or 4 to the right. The blue cart still is 1 kilogram, so 4 equals 1 times v. That means v equals 4 meters per second. So they come in with an overall momentum of 0, so they're balancing each other out. So they leave, and then their momentum is still sums to 0, which means if the green cart has 4 kilogram meters per second left, the blue cart needs 4 kilogram meters per second right, and because it only has a mass of 1 kilogram, it must have a velocity of 4 meters per second. So you're doing that same thing for your 4 example problems.